Quarterings on Friday, but my grades aren't due for a while, so I can still give something if I need to. Okay. Here we go. On last time we were together, gosh, so long ago, Thursday, Wednesday, something. Did we did F. Did we do G?
No.
I'm on page 14 of the notes. This is page 14 of the notes. We did not do G? No, I know we did F. We did F, but we didn't do G. Okay. So, here we go. I am on page 14 of my notes. I am doing problem G. I am going to find the final cost of a meal if the food costs $23.12. There is a 7% tax. Now, does tax get added onto your bill or subtracted? Added. So that's going to be a plus 7%. And then I'm going to leave a tip that's 15%. Is the tip added on or subtracted? Added. Now, you're going to do this in one step. Okay? So what do I multiply by that reflects a 7% increase? 1.07. Remember, if you are adding, it's 100 plus the percent. If you were subtracting, it would be 100 minus the percent, but we don't have any subtractions in this problem. So what am I going to multiply by to reflect the tip? 1.15. So then we just take out our trusty calculators and we type in that right there. And in one step, you can tell me how much this meal is going to cost you.
It's for free.
3? Should be 3 something. That would be a deal.
Oh, that's why I did final zero.
Okay. So $28.45. Does that sound about right? That's what you got? That is correct. Okay, so we did a bunch of those the other day, so I just want to recap the main idea, because there will be a question on your test. One question that's just like this. If you have a discount, so let's say you were buying something that was on sale for 30% off, what would you multiply by if it's 30% off? 0.7. Because that's 100 minus 30 is 0.7 or is 70, 0.70. So when it's a discount, if you're taking something off the value, off the price, it's 1 minus the percent. If you are adding on like a tax or a tip, then it is 1 plus the percent. Okay? 1 minus if it's coming off, 1 plus if you're adding it on. Okay? All right. So now we have problems H and I, which are a different kind of problem. And when you read it, you can see, oh, this is a different kind of problem. So what's happening? These are called mixture problems. And mixture problems are very much like a formula. I mean, they're all done exactly the same way. They all involve mixing 2 or 3 or more things together to come up with a final solution. So back in first year algebra, you had problems where you had weak Kool-Aid and strong Kool-Aid, and you mixed them together and you got medium Kool-Aid. Or you had a nut mixture that was this much money and another one that was this much, and you mixed them together and you got this total mix. Mixture problems, you're mixing A and B and getting C. Every one of them can be solved with the idea of amount times percent plus amount times percent equals amount times percent. These are the two that we are adding together. So this is the first solution, this is the second solution, and then this is going to be the final solution. So every one of these problems, if you're only mixing 2 things, every one of them is going to consist of 6 numbers, 3 amounts, and 3 percentages. And almost all that information is right there in your problem. Read problem H. You have 12% lemonade, and how would I put, what number would I put for 12%? 0.12, that's 12%. This isn't a discount or something, this is the actual percent. Okay, so it's 12%. And then what about 20%? 0.20 or 0.2. And then 18%, 0.18. So there are the percentages. There is not one hard thing about that. You read the problem and you copy them down. These are the 2 that get added to get the final product. Also in the problem will be 1 amount. So what amount did they give me? 18 gallons. And all you got to do is make sure you get the 18 gallons in the right spot. The 18 gallons goes with the 20%. So far, there has been nothing for me to even think about. It's just been plug and plug and plug. Okay? Now I have to think a minute. The question says, how much 12% solution? So would you be okay if I called that X?
Yeah.
How much? I'm looking to see how much that is. Now, there's still 1 blank to fill in now. Well, it could be Y, Sam, but then I'd have to come up with another equation. Okay? You can put Y there, but you have to come up with another equation then because you'll have 2 variables. So instead, another way to think about it would be just use your common sense. I have a big bucket here. I'm dumping in 18 gallons of the pink and X gallons of the red. How much do I have all together? If I dumped 18 and X, how much is all together? What? Is it 18X? 18 plus X. It would be 18 plus X. So if that's at all confusing to you, I want you to think, what if I had 7 pink and 6 red? How much would I have all together? 13, right? 7 plus 6 when you just add them? So I have 18 and X. I'm just going to add them. And I did 18 plus X. Okay? Now, solve it. So multiplying these is just 0.12x. Multiplying these, you have a calculator. I don't expect you to do that in your head, although it would be great if you could. But it's okay if you can't. 3.6?
Yeah.
Now, this is a distribute, so you're going to have to distribute this. So 18 times 0.18 and x times 0.18. So we have this equation. Would you agree with that? You okay? Now let's solve it. So I'm going to move these guys over there. Now, if I don't trust my arithmetic, I'm going to use my calculator. Be careful, because when you subtract this over to here, you're going to get not 6x, you get 0.06x. Okay? So if you're prone to mistakes, you might want to just type all that stuff in your calculator. Make sure you're getting the right decimal. Now I got to bring this guy over to here. So again, you can use your calculator. So I have 0.36 equals 0.06x. Is that what you have? And then I will divide. And my answer is 6 gallons. It's going to take 6 gallons to make that happen. John, next time you do your stretching. You don't. You're solving regular equation. You're not. So you're just taking 0.18 minus 0.12. You're just doing the numbers right now. We're not graphing at all. We're just using the regular add, subtract, multiply, divide right now. We're going to graph in a minute, but not right now. So you're just subtracting 0.18 minus 0.12. What? I I gotta get this moved over with the number, so I'm gonna subtract, and it's solving the equation, just like, regular. Don't be confused, it's a regular equation. All right, well, there's one more of these luckily, so let's do one more. Letter I. We do not have time to do J and K, so feel free to mark off J and K. You're not responsible for those. We don't have time to do them. But I can tell that problem I is a solution problem, a mixture problem. So I set up my framework, and my framework is amount times percent plus amount times percent equals amount times percent. Easy, right? Now, let's start filling in some numbers. Do I know all my percentages? I do. So I have 0.22, 0.74, and 0.50 or 0.5. Is there any question about that? Everybody keeping up with me? Easy. Now, there should be one amount that I know. What is the amount that I know? 100. And you gotta get it paired up with the right percentage. So the 100 goes with the 50. So it goes right here. Okay, that's in a different place than it was last time, right? Remember that? Okay, that's gonna have an impact on what happens here. But I still wanna know how much 22%, don't I? So I'm still gonna call this X. All right, now remember, I don't know what goes here, but when I add these together, I get 100, right? So just for a moment, I'm not gonna leave it this way, but just for a moment, let me put a Y there. Sam wanted to do that before. Isn't it true that X plus Y then has to be 100? I mean, it says I'm adding these together, and this is what I'm ending up with, right? So what would that Y be then? What should be here? I really don't want to call it Y. I want to use X's. What would that equal? Solve this equation for Y. Get Y by itself. What would it equal? 100 minus X. That's what goes here. 100 minus X is what goes there. Those two added together, these two right here, have to add up to this one. These two are added together to equal this one. So I don't know what this is, but when I add it to X, I have to get 100. So I said, okay, when I add it to X, I have to get 100. That means it must be 100 minus X. That's why that's right there. Now, when the 50 or whatever it was, when the number was here, what ended up over here? X plus that number? Because that's what happens. X plus the number equals the total. Those two add up to the total. All right, let's solve it. So 0.22x plus, okay, this is a distribute right here. So 74 minus 0.74x equals 50. All right, Ashley, how do we solve this equation? If we're going to solve this equation, what do we need to do?
Get the x's together.
Okay, now they're already on the same side of the equation. So we're not moving them, we're just adding them together. So we have 0.22 minus 0.74, so that'll be negative 0.52. Did I do that right in my head? I think so. Now what, Ashley?
Move this one.
Yep. I'm going to subtract that over to the other side, so that'll be negative 24. and then divide. So I'm gonna use my calculator to divide. The negatives will cancel.
46.
And you got it right, Sam, good work. 46.15, and is this one gallons also? I gotta put a unit on it. Was it gallons?
Yes.
Okay, good. That's the answer. Now, those are gonna be on our practice tests when we do them, so you'll get another round of practice for those. But what you need to remember to get yourself going is amount times percent plus amount times percent equals amount times percent. Okay? All right, turn back to page 14. Now we are going to do the most famous pre-calculus problem of all time, the box problem. There will be a box problem not only on your test, but also on your semester exam. I promise, 100% you are going to do a box problem on a semester exam. Because every pre-calculus kid in the school is going to do a box problem. Because every pre-calculus kid in the whole wide world does a box problem. So here's what the box problem is. Everybody take out a piece of paper. Just take out a piece of paper. Please not a good one, because you're going to be ripping it up. So
Let me get some.
use your notes. Let's get out a plain old piece of
Oh wait, I can know right by it.
She said nothing.
What?
If you don't have a piece, ask your friend
He
first.
wants to get it tomorrow or Wednesday. Like Thursday's the.
No, only me. I'm telling you.
Alright, so everybody needs a piece of paper. This isn't fun if you don't all participate. This is our one and only experience with arts and crafts. Yeah, so those of you that say, oh, Miss Blair, I hate math, but I love art, today's your day. Alright? So here we go. Everybody's got your piece of paper. I would like you, at this moment in time, to, on one corner, pick a corner, any corner, I want you to tear out a square. As perfect a square as you can. Now, we don't have time to make it perfect, but just tear a square out of the corner. See what I did here? Everybody see? Now, it can be as big or little as you want. So you can take out a big square and you can take out a little square. Take out whatever size square you want. Alright? Sam's got a square out. Now, take the same size square out of each of the other corners. Now, again, it doesn't have to be perfect, just try to make it somewhat close. We're not measuring, we don't have scissors. True story, when I used to do this, I actually did borrow a bunch of scissors, and one of my students cut the girl's hair in front of him, so we quit doing scissors. True story. I couldn't make this stuff up if I tried.
Did he get suspended?
He got in trouble, I can't remember, I don't think he got suspended. I think they were good friends and she was not pressing charges or anything. Alright, so you got the corners ripped out. Let's go, guys. Yes, I learned a new vocab word yesterday. Somebody was talking about, some kids were talking about how this one boy was talking to several girls. And I'm like, well, you aren't even allowed to talk to more than one girl.
That's just like math. You like
Talking,
more than one problem.
talking means dating.
Just like math.
Yeah.
You can
I
do
didn't
more than
know
one
that.
problem.
Like, it's like the state
Oh,
coordinating.
Okay.
It's
Yeah, it's a pending
Now,
relationship.
once you have the corners ripped out, fold up the flaps so that you have a picture that looks like, or a picture, a box like this. Fold up the flaps and you have created a box. Okay, you got your flaps folded up and you just have a little open box with no lid on it. Just a little box, okay? You just fold them up. Now, here is the interesting thing. We all started with exactly the same size piece of paper. We all started with an 8.5 by 11 piece of paper. And yet, look at my box and look at Anthony's box. They are quite different, aren't they? And in fact, Sam's box is going to be different from those two. And in fact, all of your boxes are going to kind of be different, right? What makes the boxes different? What's kind of the key?
You stripped out your square.
The what, Kennedy? How big the squares are you cut out. So if I were a really nice teacher, I would have brought in a bunch of M&Ms today, and I would have walked around and filled your boxes with M&Ms, and then had you count them. Do you think everybody's box would hold exactly the same number of M&Ms? No. So the math problem that comes out of this is, how big do the corners have to be so that the box holds the most? We want to maximize the volume of the box. That's what we are doing. Our job is to maximize the volume of the box. So that's what we're going to do right now. Okay? So we're going to go back to our notes, page 14, and we are going to do problem D. And while we are doing problem D, I am going to pass around some treats that I made you. It's just banana bread, nothing big. But I made this to celebrate the accomplishments of our kids in the play. Because the play last night, let's see who's in here in the play. Right here we go.
I think only 3 of us this morning.
What was that?
Brendan was, you two were, anyone else? So, I'll pass this around to anyone who wants to use.
Don't even start.
That's fine. I'm doing it around.
What are you doing?
It has no nuts in it. And I do want to say, as it's coming around, you know, I got 4 kids, 2 of whom are vegan. So over the years, I've done some vegan experimentation. That is actually vegan banana bread, but I don't think you'll be able to tell it. Most people can't tell the difference. The consistency's a little bit different, but the taste is the same. But if any of you are vegan, that is vegan.
All of them.
What's vegan?
Okay, so here we go.
Nope.
Set your boxes aside.
I had a part. That's why I had to
Guys, we won't ever have treats again if this is the chaos that erupts. Here we go, we're on problem D. We have a 12 by 14 piece of paper. We are going to cut square corners out from each side, just like you just did. We are putting on the board what you just did. Your paper wasn't 12 by 14, I'm using what's on the notes here, but it's the same idea. These are some size that we have to figure out. We do not know how big they are. Does everybody understand the situation? Now, if I could fold my blackboard, I am cutting these out. So here are the flaps. That's what's getting folded up. Just like you did. These are the creases when you folded up the sides. These are the pieces you ripped out. Okay? Now, 3 questions. Number 1, write the equation for the volume of the box. This is easy. You remember from geometry that volume is length times width times height. So, I need to know the length, the width, and the height of my box. This is going to be my equation. Okay, this is where I'm going to eventually type into my calculator. So, the original piece of paper was 14 inches, but you cut an X off this end and an X off this end. Think of your piece of paper. it was however long it was, but you chopped a piece off this end and a piece off this end. So how will you describe this length now? It was 14, but you took an X off here and an X off here.
14 minus 2x.
14 minus
2x.
2x. 14 minus 2x, because you took an X off each end, right? Now, what about the width of the box?
12 minus 2x.
Same thing, only it'll be 12 minus 2x. Because it was 12, but you took an X off here and an X off here, right? Now, kids, stop. If I change the dimensions of the paper, let's say the paper is 10 by 20. Then it's going to be 10 minus 2x and 20 minus 2x. That's never going to change. It's dimension minus 2x, dimension minus 2x. Does that make sense? Because no matter how big the paper is, you're still taking an X off each end. Now, height. Think about when you fold that up, this is the height of the box, right?
Yeah.
What is that? Isn't that?
That's x.
No, it's not 2.
That's x.
That's X. That's X. The height of the box. Think about taking this flap right here and folding it up so it's like my hand. Isn't this coming up? Isn't this going to be the height?
Yep.
And that is X. So the height will always be X. There is your equation. So part 1 says, write an equation for the volume of the box. So it's length minus 2x, width minus 2x, x. Every single time. Okay? Now, the next question says, what's the domain? Now, the domain, x has limitations on it. I want you to think about this. X is the corner, X is this little piece of paper. I don't know where mine went. The X are the little, here they are. This is X right here, X by X, right? So could X be negative 7?
No.
No, in fact, X can't be anything less than
0.
0, right? So the lower bound for your domain is always going to be 0. Because whatever X is, it has to be positive, right? You can't rip off a -1 corner. It has to be positive. Now, what about an upper bound? Think about this piece of paper right here. Could X be 50?
No.
Why not?
It can't be bigger than 14.
It can't be big. Okay, the biggest dimension is 14, right? Okay, so let's talk about this. Could X be 10? Now remember, aren't you taking an X off each side? If you only have, well, if I only have 12, can I take 10 off each side? No. If I only have 12, the most I can take off each end would be 6. So the upper limit is 6. Where did that 6 come from? It's half of the smallest dimension, right?
Oh, that makes sense.
Yeah, the larger dimension, half of it would be 7, but 7 won't work on the 12 side, right? So you gotta look at the smallest dimension. And remember, whatever the smallest one is, you're taking a piece off each side. So if it's 12, you can't take more than 6. What if it were 20? It'd be 10. If it were 52? 26. It's easy. It's always going to, your domain is always going to be from 0 to half the smallest dimension. We're zeroing in on the smallest dimension. That's my domain. Okay? Now, the last question says, find the maximum. So this is where we are going to go to our calculator. Before you get wild and wacky, I want you to go to mode. Go to mode. Mode is in the top row of buttons. Mode, right next to the second button. See mode. Make sure FUNC is highlighted. FUNC. So go down. It's, for me, it's the 4th one down. I don't know what it is for you. FUNC, function mode. You gotta be in function mode.
What do you click?
You just go down to function and enter.
Does it have to address function or you can do it multiple ones?
only one can be highlighted per row. Okay, you can have something in every row should be highlighted. The only one that matters in this problem is the function row. I need function to be highlighted, okay? Other stuff at this point really isn't gonna matter, so we got function highlighted, okay? Now, let's go to y equals. That's y equals, you know, that's where you put in your equation. If you got something in there, hit clear, and then type in this equation exactly like it is. So parentheses, 14 minus 2x, and remember, x is the button right under mode. X is right under mode. So you have 14 minus 2x, close the parentheses, new parentheses, 12 minus 2x, close the parentheses, and x. This x does not have to be in parentheses, but you can if you want. It doesn't matter. Okay. Now, everybody got it in. Now we're going to window, which is the button right next to y equals. This right here is x min and x max. Okay? So x min is going to be 0. X max is going to be 6. X scale, just leave it 1. Just leave that at 1. Do not ever change that. Just leave it at 1. All right, so X min right here, well, X max right here. Okay? Now, Y min. Remember, Y is your volume. What is the smallest volume that anything can have? 0. So Y min is always going to be 0. You are never going to have a negative volume. So Y min is 0. Y max is the answer to the question. We want to find the maximum volume, the maximum Y. So right now, we're just going to take a guess. So let's try 100. Now, I'm telling you right now that isn't big enough, but I want you to see what happens. So for Y max, we just guessed a number, 100. This is not a guess. This is not a guess. This is not a guess. Those are the setup. Y max, you're going to guess a number, okay? Now, hit graph. Now, what graph is right over here at the top. Last button in that top row button. And when you hit it, here's what happens. You should see something that looks like this.
So what do we put 100 in?
Wait, I need, those of you that are with me, stay with me. Those of you that aren't here, just wait. We're going to do another example. You need to, we went through all this back in chapter P. If you've forgotten, that's okay, though. I'm not going to back up and do it again. Just listen. Some of you should have this graph on your paper. You should see it going up and then coming down, but this is missing. And this is the answer, because we want to find Y max. So I'm going to go back to my window, and I'm going to pick a higher number than 100, because I'm not seeing enough here. Do you see what I'm saying? Yeah. So I'm going to go down to Y max, and I'm going to try 400. Now, that is a flat out guess. You might try 500 and you might try 300 and somebody else will try 700. I don't care. All that matters is when I hit graph, I need to see the top of a hill. So if you can see the top of a hill, you got it. So if you guess a Y and you're still not seeing the top of the hill, go back in and guess again. You got to see the top of the hill, because that is the maximum. Okay? Now, here's what you do next. We've done this before. I want you to press second calc. calc is the button right next to the graph button. It's in blue. The button actually says trace, but above it says calc. So when I hit second calc, it pulls up this menu of many options. When we did it before, we chose 0, but this time we're going to choose maximum. So I hit maximum and enter. And then the cursor comes flashing on the screen and it says left bound. So use your little arrow buttons and move it so that the cursor is over here somewhere. You need the cursor over here, anywhere over there, and press enter. For some of you, a line will come into the screen. For some of you, it's just an arrow up here. Now it says right bound. So we use our arrow button and we move the cursor over here to the right. Anywhere over here to the right. Okay? And press enter. So I either get another line or I get a this. Okay? Now, move the cursor to the point that looks about like the maximum. I mean, it is approximating. Hit enter, and it will tell you that the maximum is 2.147523, 160.58366. That's what it says. So that is your maximum point.
So you have to put X in.
No. We're going to talk about that. That's the maximum point. Now we have to answer the question. So we have to go back and remember, what did the X stand for when I made my equation? When I made my original equation, what did X represent? The size of the corners. So if someone said to you, how big should my corners be? You would say 2.15 inches. But that isn't what they said. What did the question say? What is the maximum volume? Well, Y is your volume. So what is the maximum volume? 160.58 cubic inches. Volume is a cubic unit, a cubed unit. So X tells you how big the corners are. Y tells you what your volume is. Okay, now I'm going to go through the next one and then I will help anybody that's problems. But those of you that have problems, try to just pay attention here and I think you can get this figured out. We are going to do exactly the same problem, but this time our piece of paper is 20 by 24. Okay, so here's my piece of paper. It's 20 by 24. We're doing the same problem. Okay? So you're going to cut out the corners just like before. They're going to be X's. You're going to fold up the flaps. We're going to make a box. So what's my equation? What is my volume going to be? My volume is going to be 24 minus 2x, 20 minus 2x, and x. That's my volume. Length, width, height in any order. Doesn't matter. That's going to be my volume. It's always length minus 2x, width minus 2x, x. Q. This is an exam question, honey. You really want to pay attention to this. All right? Everybody okay with the equation? So now we're setting up our domain, and our domain is going to always be x is between two numbers.
0 and 20.
This is going to be 0 always because x can't be negative. 0 is the bottom end, smallest it can be. What is the top end of my domain? 10. The top end of the domain is always half the smallest dimension. The smallest dimension of this paper is 20, so my domain will be 0 to 10. All right? So now I'm gonna go to my calculator, and I'm going to set up my window. Now remember, this is always what? What's this? Well, I know it's 0, but where do I put it in here? X-min. This is always, these are your X's right here. So this is X-min, this is X-max. So the max is 10. Okay, everybody got that? Now, Y-min will always be 0. So Y-min, you don't even change it. It's going to be 0. Y-max is going to be a guess. All right, so what do you want to guess?
I just do 1,000 every time.
What? 100? All right, well, you guys guess whatever you want. I'm going to put in 700. Okay? Now, here is the biggest mistake, and this is kind of unbelievable, but this happens all the time. At this point, kids will hit graph. And unfortunately, it won't graph the right equation because you haven't put this equation in. You've got to put this equation in. Otherwise, you're going to be graphing the wrong equation and getting the wrong answer. So we go to y equals, you can clear out everything that's in there, just hit clear, and then type in your new equation. 24 minus 2x, 20 minus 2x, and x. And again, that last x, the last one, you can put it in parentheses or not put it in parentheses. It doesn't matter.
I'm sorry.
Yeah, you are. That's a detention.
Okay.
Nothing is more important than this right now. Okay. Everybody got it in? Now hit graph. And the only rule is, guess what? This is what I saw when I graphed. What does that tell me?
Not higher.
I should have picked a bigger number. So somebody said 1,000. I should have picked 1,000. 1,000 works. Now I see it.
Oh, so Y-min is always 0.
Okay? So now we're going to find our maximum. So what buttons do I press? Second calc, right? Second trace. It's the trace button, but I'm using the calc part of it. And then I go down to maximum. And then I use my arrow buttons to move the cursor to the left. And kids, please don't sweat it. Anywhere over here. Anywhere over here. Set it. Okay? And then move it to the right. Oh wait, I forgot to hit enter. And then move it to the right. Anywhere to the right. And then move it in between. And it should say at the bottom that 3.62 and 774.16. Those are your X and your Y for your maximum, right?
Every time.
So now we just have to answer the question. So the question was, find the maximum volume of the box.
What's your Y value?
Which one of these numbers is the volume?
The Y value.
The Y value. Now, I'm not promising you that that will be the question on the test. The question on the test might be, how big of corners do you cut out? If the question is how big are the corners, this is the answer, right? This is the X. These are the corners.
So that's like
This is the actual volume. So your answer is always going to come from these two numbers. You just have to read the problem to know which one it's going to be. Does that make sense to you? So 774.16 cubic inches. That is the maximum. That is the answer to the question.
When we hit calc, do we go value 0?
Get maximum. We're looking for a maximum. All right. So, Shiloh. No, school's gonna be out in 4 minutes. Time flew today, didn't it? Time flies. All right. So I'm gonna come around and help anybody that needs help. While I'm doing that, I want everybody to be working on the same thing, except we're gonna do our piece of paper, which was, how big is our paper? 8 by 11? Is that what it is? It's not 8 by 11.
oh, that's what you said.
Alright, let's say it's an 8 by 11 piece of paper. Do the problems. How big should those corners be? If your paper, oh no, it's 8.5 by 11. That's what it is. 8.5 by 11. So let's see if we can actually solve our problem. And then if we have time.